Hi everyone, we're going to look at how to calculate the line of best fit for two different scatter plots here. What we're going to do first is kind of sketch in where our line should go. So you want to make your line go as close to the dots as possible and also keep it pretty balanced. So like this wouldn't be very balanced, this also wouldn't be very balanced. You want to keep the dots kind of even on both sides of your line, on the top and on the bottom. So again, this wouldn't be very good, but this would be a little better. You want to touch as many dots as possible and again keep it balanced with dots above and below. That's a pretty good line of best fit. Now to find our equation of this line, we're going to need a couple things. We're going to first need the y-intercept. We're going to need to know where does the graph cross the y-axis. So it's right over here. Looks like it's a little bit in the middle here for between 140 to 150. Not quite 150 though. That would be right about here. It's a little bit under that. So maybe we call this 148. I mean, we're pretty close either way. So I'm going to call it 148. And then for our slope, we've got to figure out the another point here in order to find the slope between these 2 points. So our y-intercept is at 0, 148. That's 1 point. We've got to use one other point here to find the slope. So I'm going to look for any place on my line that I know for sure where it goes through using the grid on here. So I look right here. This looks like if I go at 60, 80, it looks like the line goes directly through that grid marker there. Now there's not necessarily a dot there, and that's okay. I just need some place on the grid that I know for sure where my line goes through. So I'm going to use that point, 60, 80. And I'm going to find the slope between these 2 points. So I'm going to make a little table. So 0, 148 and 60, 80. And then to find my slope, I'm just going to find the y change and the x change. So the y change from 148 down to 80 here is going to be 68, but it's going to be going down 68. So we're decreasing here. And then our x change is going from 0 to 60, so that would be plus 60. And our slope is always the y change over the x change. So negative 68 over 60. That's how we calculate our slope. It's always taking the y change and then dividing it by what the x change is. Now from here, you could simplify this down. We don't necessarily have to. We could just kind of leave it as a fraction. But if you want to make it a little bit simpler, that's fine too. I'm just going to divide these. That gives us a decimal, if you like to use a decimal, negative 1.13 repeating. And now we've got our equation. Y equals the slope times x plus the y-intercept, 148. And that's how we find the equation of the line of best fit. That would be for an example going down. So this would be negative and strong for our correlation. The next one here, we've actually got one going up. So same kind of idea. We're going to first draw on the line of best fit. It's always good to draw it so that it goes across the y-axis, so you can use that point in your equation. So you want to see where it crosses. That's a pretty good line of best fit. Our dots are pretty close to the line. My y-intercept here is just, looks like it's a little bit underneath 5, maybe it's 4. Let's call that 4. It's not quite at 5. And then again, we need one other point on this line. So I'm going to look over this graph here and look for any place where the line crosses the grid at a very noticeable spot. And I see one right here at 2015. It looks like that crosses that grid perfectly right there. So I'm going to use that point as my second point. So we got, in our table, we're going to use the y-intercept and that other point, 2015. So 0, 4, and 2015. So then we're going to do the same thing. We're going to find the change in y first. Change in y goes from 4 to 15, which is plus 11. Our change in x is from 0 to 20, which is plus 20. And then our slope is always the y change over the x change. So that's going to be 11 over 20, which we can leave just like that if we like. A fraction is totally fine. So let's write our equation now. Y equals 11 over 20. X plus our y-intercept, 4. But again, if you really like to get a decimal out of this, you can always do that. If I just do 11 divided by 20, I get my decimal, which would be 0.55x plus 4. Either way, we've got our equation of the line of best fit.